Now that we've learned some basics about types of data that's out there and some ways that we can visually represent that data using some graphs and charts, now we're ready to calculate some specific statistics. Specifically today, we're going to focus on statistics that measure the center of a set of data, or that represent the central tendency of our data. So these measures the center, I think a lot of these statistics will sound very familiar. The first one that we're going to look at is going to use this set of data. There's 45 values in this sample, and this data is showing the cost per semester of single student housing in Ephraim in 2013. Okay, so there's a lot of costs there. The first measure of center that we're going to talk about is the median. Okay, so what is the median? Well, that's what the important part about the median. You do have to have your data sorted. It has to be in order. Okay, no, I've given you this set of data from smallest to biggest already in order. The median is the middle value. Okay, just the number in the middle. So you do some counts. If you realize that we have 44 data values, that means that we'll have one number, the 23rd number, will be exactly in the middle, because then there will be 22 values smaller than it and 22 values bigger than it is. So if you have an odd number of values, like our data set, our 45 values here, if you have an odd number of values, there's always going to be exactly one of those that falls in the middle. In this case, it's our 23rd number, so 18.12, which I believe is this one right here. Okay. So that value right there is in exactly the middle. So there's 22 values less than it, 22 values bigger than it. And so our median then will be that middle number. And so we'll have 1,000 as our median. Okay, there are some other values that would also be interested in, and those are quartiles. So the median is actually also referred to as quartile 2. Okay, there's 3 quartiles. So this next little bit is just to understand, what is a quartile anyway? Well, you can see the root of this word, right? A quarter, a fourth. So quartiles split our data up into 4 equal size intervals. So I'm going to give you a visual. So let's say we have a board here. That's just a regular wood board, right? A 2x4 or whatever. If I want to divide that into 4 equal pieces, how many divisions or how many cuts would I need to make? Well, I would have one right in the middle, and then each of those halves I would then have to cut in half again. That's what my quartiles do. So how many cuts did I need? Well, I only needed 3 cuts to divide my entire length into 4 pieces. Okay, so just to help you understand, so there are only 3 quartiles, because it only takes those 3 numbers to divide our data into 4 equal intervals, subintervals. All right, so using that same idea, if we're talking about percentiles, well, we only have 99 percentiles, but if you visualize your board, you'd make 99 cuts in it. How many pieces does that divide your board up into? Yeah, that'll be 100 pieces. But again, you only need 99 percentiles to break up the board into that many. So this should have been 4. So my 3 cuts divided the data into 4 equal parts, or quartiles. My 99 cuts divide my data up into 100 equal parts. All right, hence quartiles and percentiles. So in the context of what we're working with, we're only going to make you work with percentiles that equate to one of our quartiles. So keep in mind, quartile 1, what percentage of my data is lower than quartile 1? 25%. So that's the 25th percentile. How about quartile 2? What percentile is the same as quartile 2? Yeah, the 50th percentile, because there's 50% of the data that's less than that is. Quartile 3, there's 75% of the data that's less than that. So percentiles, if you've ever taken the SAT and you got your score, it told you what percentile you fell in. So that percentile number tells you how many people scored lower than you. All right, so if you finished up that test and you ended up in the 92nd percentile, you did pretty darn good, because you did better than 92% of everyone that took that test. Okay, so practical applications for these percentiles, quartiles. Okay, so now comes, how do we find these quartiles? We know the middle value is quartile 2. Well, how do I find quartile 1? Simple. You just take all of the values that are less than quartile 2, that bottom half, and you find the median of that bottom half. Find the middle number. Okay. Now, keep in mind, if you have an odd number of data values, let's say we have 5 data values, there will be exactly one number in the middle, which will be quartile 2. That'll be your median, right? And then you don't include the median. We take the bottom half, and we want to find the number in the middle of that. But in that case, there's only 2 values, right? So if there's an even number of values you're trying to find the middle number for, you take the 2 middle numbers and you average them. And that will give you that quartile, right? So in the case of 5 values, I'll take those. It's an even number, so I'll take the 2 middle numbers and average them, find the value in the middle of them, right? And that will give me quartile 3. Okay, so just remember, if you have an even number of values that you're working with, the middle, the median, or the quartile that you're after is going to be the average of the 2 middle values. If you have an odd number of values that you're working with, there'll be exactly one of those values that falls in the middle. All right, so there's that. And now it actually wants you to find, so the median of the first 22 values, or quartile 1, it wants you to find it. Okay, and you could do this counting like we did with the median, right? Well, I'll count 11 values. There's 8, 9, 10. The 11th value is at 850. The 12th value is at 850. Those are my 2 middle numbers, and I need to find the number exactly in the middle. So their average clearly is still 850, right? So that's not too bad. Now, what about the higher 22 values? So these 22 values that are bigger than 1,000, well, that will also be between the 11th and 12th value higher than 1,000, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 11 and 12 fall at 1135 and 1160. So I have 2 middle values, again, because I'm only working with 22 values in this upper half, right? And so my quartile 3 is going to be the average of those 2 numbers. What's the average of 1125 and 1160? So add them up, divide by 2. What do you get? Nice. So we end up with 1,147 and a half. Because that's the value in between those 2 middle numbers. Pretty slick, right? Well, now keep in mind, you can also calculate those on your calculator. So when you're finding medians, you could do it by hand. It could be a little bit tedious, especially if you have a lot of values that you're dealing with. So let's jump to your calculator for a little bit. And we're going to enter that data into our calculator. Okay, so you'll hit your stat button. No. Oh, let's turn it on. You'll push the stat button on your calculator and press enter on edit, or just the number 1, right? We're going to use that first option. And you need to enter in all of those values in list 1. Just type the number and press enter and go all the way down. When you have this many data values, it's going to be well worth your time to check and double check your list. Make sure you've typed in all of the values correctly. Otherwise, if you get one value wrong, it's going to throw off all of your statistics, okay, that you're going to calculate using that set of data. So I've already double checked these, so I know that my data is in here right. Now we're going to hit second and mode to quit out of that, and then push our stat button. Now we have 3 menus here, so the edit menu was where we went to enter in our list. We're going to go over to the second menu. Just hit that right arrow, and it goes over to the calc menu, and we're going to choose the first option, 1 variable stats, number 1. Press enter on number 1. We need to make sure it puts in the right list. So if there wasn't any list entered in there, okay, if you look above your number keys, in mine it's in blue, right? But there'll be an L1 and an L2 and an L3. Those are our list variables. So if I hit second and the number 1, it'll put in list 1 there. Awesome, right? So we don't need a frequency list. We're going to leave that blank. And that's going to be the most common option here. We won't usually have a frequency list. There's a couple cases where I'll tell you about that. But for now, we're just going to leave frequency list blank and press enter on calculate. And it will give you a list of summary statistics for that list 1 where we put our data. Okay. For now, don't worry about those top numbers. I'm going to direct you down to the very bottom. So again, just hit your down arrow to scroll between these. You see that little arrow there? That means we can scroll down. So I want to see these last options, and what do you notice? Well, look, there's the quartile 1, the median, and quartile 3 that we just found. So your calculator did it for you. However, it did take a little bit of time to put in the data, but once the data's in there, we can compute a lot of statistics pretty quick from that data. And so this minimum value and the maximum value is also important. And so these last 5 numbers, those make up what's called our 5-number summary. And that 5-number summary is going to be necessary for us to make a box plot, which is another chart that you can use to represent your data, to give you an idea of the distribution and the spread and the center of our data, where everything's at. So we're going to fill in these numbers. Nice. So now we're going to maximize this again. We have our 5-number summary, so now we can make a box and whisker plot. So basically, you're going to create a number line and put your data on that number line. So let's put in a scale here. So we need to go from 700 up to 1800. So maybe we'll just do 1 for each 100. So 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. And again, this is just going to help us to scale this properly. Again, labels and scales, we've already had that discussion, right? It's always important to get these on there to get everything falling where it needs to fall. maybe an 1800 since we go a little bit larger. And so now I'm just going to mark with a slash where all of these fall. So 725 is about here. 850 is right here. 1000 is there. 1147.5 is about here. And then 1794 is over here. So those middle three lines, just make a box with them. That box represents the middle 50% of my data. And then I'm going to draw a whisker to the minimum and a whisker to the maximum values. So here at the low end, that's my minimum. That's my 725. Then I have quartile 1 on the left edge of the box. That's 850. This slash inside the box, that represents quartile 2, or the median, right? And that's my 1000. On the right edge, we have quartile 3. And my right whisker is my maximum value. Whoops, right, that is the maximum. So I recommend every time you build a box plot, again, label it, right? First I should know that this is representing my housing costs no, that just straight up, right? And so I recommend anytime you make a box plot, you need to tell me what your 5-number summary is, so it's clear that you know what the minimum, Q1, Q2, Q3, and the maximum values are, and then label where they happen on your box plot. Make it very, very clear which spot is which number, okay? So box plot, not too bad. No, if you forget what we just did on the calculator, here is an explanation on your individual prep worksheet that explains where to find that 5-number summary on your calculator. Notice as you look at this, we have some values that are quite a ways away from this middle 50%. Okay, that 1794, that's a long whisker. Okay, and so maybe we need to do an analysis to see if there's any of what we call an outlier, any outliers in our data. Often outliers are way far away from most of our data, and they're just causing our results and our statistics to be skewed a little bit. So in a lot of cases in statistics, we will either just eliminate the outliers completely, or there's some other things that you can do to handle those outliers so they're not negatively impacting our statistics. So first, how do we find an outlier? Well, we need to find what's called an interquartile range, which is simply the width of the box on your box and whisker plot. Okay, so in mine, or in this set of data, Q3 was 1147.5, Q1 was 850. So my IQR, 1147.5 minus 850 will give me 297.5. And again, that's my interquartile range. Okay, I'm going to use that number to figure out where my outliers would fall. Okay, so basically an outlier is any of my data values that are at least that far, the 297.5, that 1.5 times that distance away from the box, from that middle 50% of my data. All right, so I'm going to calculate some values. So I know that, well, first I better find 1.5 times my IQR, because that's going to be a number I'm going to use in this calculation. So in this case, that gave me 446.25. And so now I'm going to find that distance from either side of my box, on my box and whisker plot. So that much more than Q3, Anything beyond that spot would be an outlier. So I'll have my Q3 1147.5. Add my 1.5 RQRs to that. And that gives me a value of 1593.75. And now I'm going to go that far below Q1 as well, right? So we're going to take Q1, my 850, and subtract 446.25. That leaves me with 403.75. Awesome. So now, once I have those values, anything above that first one or anything lower than that second one would be considered an outlier. That is too far away from my middle 50% of my data, right, from the box. So what outliers do I have in my data? Well, let's look at it. If we look at our data, are there any values less than 403? Well, I look at all of those data. My lowest value is 725, so the answer is no on that one. I don't have any values that are lower than 403, but what about values that are higher than 1593.75? Well, I did have some of those, right? I have this 1794 is an outlier. It is too big, right? So I would list that down here as an outlier. That makes sense? It's pretty slick, right? Not bad at all. Okay, so now we've identified outliers. So again, oftentimes when you're doing data crunching, that 1794, you just eliminate it from your analysis, from your calculation of your other numbers. So cool thing, you could make a box plot on your calculator. So we already have all this data in here. So anytime you're most of these stat plots, if you want to make them, see this stat plot option written in blue above my y equals button? Yeah, if I hit second and y equals, that gives me all of these stat plots possible. Hopefully, they should all be off right now, but let's press enter on number one, press enter on, let's turn it on, and now go down to the types, and which of those look like my box plots? Well, the first one, so let's hit number 5, that fifth one, the one without the dots, right? If we do that, let's make my data is, my X list is going to be list 1, that's where all my data is. Leave the frequency alone. And now I'm going to graph this. Well, first I need to make sure my zoom on my graph is right. So I'm going to hit zoom. And anytime you're zooming onto a stat plot, go down in this list and find zoom stat. Okay. And it will adjust the graph view so it fits that plot. Note that looks pretty close to that box plot that we made, right? If you hit the trace button, and just hit your arrow keys, it will tell you what your 5-number summary numbers are. So that's pretty cool. Well, did you notice that there was another plot that looked like a box plot there? So let's go back to second and y equals, go back to our stat plots, go back to plot 1, and now change the type to this fourth one, the one with those 2 dots to the right of the box plot. Basically, that one will take out outliers, okay? Again, because that's often something that we need to do so our outliers don't negatively impact our analysis. So we're gonna zoom stat again, whoops. Let's go here, zoom stat, number 9. And so I have my box plot here, but now if you look at that right whisker, now it is that 1519. not the 1700 number, right? The 1794. And then if I hit over again, it shows me that dot, that 1794, it tells me that was an outlier. So you can use that box plot feature to find what your outliers are in your data as well. And again, as long as you have the time to put in that data, your calculator can do quite a bit for you. All right, so now you have found your outliers, okay? We've found a median, so our first measure of center is the median. We've talked about quartiles, so let's review just what a few of those other measures of center will be. First one is the mean. This is one that you're pretty familiar with, right? The mean is just your traditional average that you compute with numbers, okay? Add up all the numbers, divide by how many numbers there are, and you have the mean. So you could go up and add up all 45 of our data values for the cost of student housing, right? Then divide it by 45, and that will give you the average student housing cost per semester. Okay, well, we already took that time to put our data into our calculator, so why not use it? Our calculator will also find that average. We actually already found it, right? Go to the stat button again, go right to the calc menu, and option number 1 again, one variable stats. Using list 1, leaving the frequency list blank, calculate X bar, that first option here, that represents the mean of a sample. I put in list 1, remember we're working with a sample of housing costs. Okay, it's not a complete list, it's not the entire population. Very rarely will you have data for the entire population. So again, our purpose for this statistics class is to use a sample to glean some information about the population, right? So again, X bar represents the average of our list. We know the list is a sample, so it's a sample average. And that average is 1037.16. Okay, so 1037.16 is our X bar, or the mean of our sample. Now, if this was talking about the whole population, we'd use this Greek symbol that's pronounced mu. Looks like a U with a long line there at the beginning, right? But that's actually the Greek letter M, mu. Okay? All right, so there's one. And the third measure of center, this will be the last one we talk about in this lesson, is called the mode. Do you remember what the mode is? Well, that's the number that occurs the most. Note, your calculator does not give you the mode. Okay, we're gonna zap away our calculator for now. So if I look through this, let's see, 750 occurs twice. What other repeats do I have? I have 3 825s, so 3 is winning so far. Is there anything that occurs more than 3 times? Oh, 950 occurred 3 times. 1300 occurred twice. So it looks like 825 and 950 are tying for those that are used the most in this data, right? So that would mean that the mode for my student costs would be 825 and 950. Whoops, just kidding. And 950. Note, yes, there can be more than one mode. If there's a tie for the number that occurs the most, all of those numbers that tied are all modes. So there's a little footnote here where it explains the mode. It says, yeah, you could have multiple modes. If there's exactly one number that occurs more than everything else, there could be exactly one mode. But if every number only occurs once, there is no mode. So mode's a very interesting measure of center. It has these unique situations that happen. Okay, so I've walked you through what mean, median, and mode are. So now, before you meet with your group, go ahead and find the mean, median, and mode with these other sets of data, okay? Using that same process. Again, your mean is your typical average. For the median, you need to sort your data first. Remember to sort your data, and then the median is the middle number, and then your mode is the number that occurs the most. So note, in this sequence of lists, we add one number and then another number just to see what happens to those measures of center. Note, these numbers that were added were quite a ways away from the other values. So you're going to explore some ideas of which of these is most affected by outliers. Okay, an outlier really affects one of these in particular. The others aren't quite as impacted by it. So experiment with that, compare those values you end up with so that you can then answer these last couple questions on your individual preparation assignment. Okay, you guys are armed and dangerous. Have fun working with some measures of center. And again, send word if you have any questions. Signing off.